In exercises 9 through 16, we're basically going to continue the same thing we were doing before, only here we're not given the graph to look at. And we want to identify the open intervals on which a function is increasing or decreasing. Now one of these problems, number 9, is fairly straightforward. So let's review what we've been doing so far. We have g of x is x squared minus 2x minus 8. We find the first derivative, 2x minus 2. We set the first derivative equal to 0, and we get 2x equals 2, or x is equal to 1. So that's our only critical number for this function. The only place where the derivative is 0 or doesn't exist is at x equals 1. So we're going to make our sign chart. Again, this is different than the way we found absolute min and max. Absolute min and max, we identified the endpoints, we identified the critical numbers, and we simply tested the original function at each of those values. The highest was the absolute max, the lowest was the absolute min. Here, with relative, well, we're not even talking about relative min or max yet, but here we're finding the critical numbers, and then we're going to put them onto the number line. Critical number means that's the only place where the derivative can be 0. If that's the only place it can be 0, then it has to be positive to its left or negative to its left, and positive or negative only to its right. So let's see what happens here. We're dealing with g prime of x, and we're going to use some test values. -1, to the left of 1 we'll use 0, and to the right of 1 we'll use 2. Then we're going to test the first derivative, because we want to find out, is the first derivative positive or negative. Remember, when the first derivative is positive, the function is increasing. When the first derivative is negative, the function is decreasing. So we're going to test 0. Our first derivative is given up here. We plug in 0 there, we're going to get a negative value for the first derivative. Plug in 2, and we'll get a positive value for the first derivative. And again, we can use arrows for decreasing, going down, increasing, going up, and you can tell you have a relative min at x equals 1. The first derivative changes from negative to positive. The function went from decreasing to increasing, and that produced a relative minimum at that critical number. So, closing this up, we know that the function is decreasing from negative infinity to positive 1, and increasing from 1 to positive infinity. Alright, let's go on to number 11 then. Number 11 is a little bit more complicated than is number 9. Now in the previous problems you were given a graph, and these problems you don't have a graph, but I don't mind if you use your calculator to take a look at the function before you start working with it, because in this particular case there's something very important that you need to see. So I bring up the calculator and I enter the function x times square root of 16 minus x squared. I'm going to zoom standard, and when I do that, notice that the graph only has just kind of disappears or fades out to the left of, that's -4, and to the right of +4. And there's a very important reason for that. So I'm going to take a picture of that and place it onto our workspace here. So this is the function y equals x times square root of 16 minus x squared. Now if you look at it, and we really should spend time to look at a function before we just barge right ahead and find the first derivative, etc. And that is, in this function, under the radical, you have 16 minus x squared. But the radical has to always be positive. So 16 minus x squared has to be greater than or equal to 0. And that will only happen when, so we can do a number of things here. One way we were taught to do this before is to factor this into 4 plus x times 4 minus x, and that's got to be greater than or equal to 0. Now, the first place that we actually had some introduction to using sign charts was actually with this type of problem to find out where it's going to be positive. You recall that when two numbers are multiplied together, they will be positive if they're both positive or if they're both negative. So we need 4 plus x and 4 minus x to both be positive or both be negative. And so what was often done is what we're doing now in calculus: make a line chart, a sign chart, and we label the places where those factors might be 0, at -4 or at +4. And then we use a test value in each interval. And when x is -5, you're going to get negative and positive, so that would be negative there. 4 plus x would be negative, 4 minus x would be positive. When you plug in 0, you're going to get positive times positive is positive there. When you plug in 5, you're going to get positive for 4 plus x and negative for 4 minus x, so that would be negative. So the only place where 4 plus x times 4 minus x is greater than or equal to 0 is between -4 and +4. So those are the only values that are in our domain here. So it is important to note that before we even begin. And you can see on the graph that the function is decreasing and then increasing and then decreasing again. And we need to find the values where those changes occur. Alright, so let's get back to our business of the moment here. So we have number 11. And number 11, we have x times, and I'll rewrite that, 16 minus x squared to the 1/2 power. Alright, since this is a product, we're going to need the product rule and a chain rule within the product rule. So g prime of x is 1 d2. For the derivative of the second function, the outside is a power with 1/2. We'll leave the inside alone. Reduce the power by 1. Then multiply by the derivative of the inside function, which is -2x. So that's 1 d2. We still need 2 plus the second function, 16 minus x squared to the 1/2 times the derivative of the first, which is 1. Now we're going to simplify. Simplifying, this 2 will cancel with that 2, and we'll end up with negative x squared times the quantity 16 minus x squared to the -1/2 plus 16 minus x squared to the +1/2. Now, in order to solve this for 0, we're going to need to factor out the least common multiple, which is always the smallest of those, 16x squared to the -1/2, and that leaves negative x squared plus 16 minus x squared. We multiply two numbers with the same base, we'll add exponents, so -1/2 plus what is going to equal +1/2? -1/2 plus 1. and so that's just going to be 16 minus x squared. We rewrite 16 minus x squared to the negative 1/2 times 16 minus 2x squared. Now since the 16 minus x squared to the negative 1/2 has a negative exponent, that can be put into a denominator. 16 minus x squared to the 1/2, and the numerator would be 16 minus 2x squared. So recall that a rational function is 0 when its numerator is 0, and it's undefined when its denominator is 0. In this case, the denominator, we can say that g prime of x does not exist at x equals plus or minus 4. But we just saw above that our function is only defined within -4 to +4. So we're not going to worry about plus or minus 4. We're only going to spend our attention to worry about where that derivative is 0. And so we have 16 minus 2x squared is equal to 0. Divide through by 2, and we get 8 is equal to x squared, or x squared is plus or minus 2 times the square root of 2. So hopefully the algebra involved in that is okay. Now to estimate, we have only those two critical numbers, and we're going to place them -2 root 2 and +2 root 2 on our number line with g prime of x. But we need to choose some values, so we need to get an estimate, and square root of 2 is roughly equal to 1.4. So 2 square root of 2 is going to be roughly equal to 2.8, which means that we can use -3, 0, and +3 for test values. And again, we just have to go back to our derivative. And our derivative is right here. When we plug in -3, 3 times 3 is 9, 2 times 9 is 18, so the numerator is going to be negative. The denominator, square root, will always be positive, so we'll have a negative here. Then at 0, the numerator will be 16, denominator is always positive, and so at 0 it will be positive. And at +3, we'll get 16 minus 18, which is also negative again. And so we can see that this function is increasing from -2 root 2 to +2 root 2, and it is decreasing in two places from -infinity to -2 root 2, and from 2 root 2 to +infinity. And so there was a lot of work involved in that one, but hopefully this is going to be instructive. Alright, we'll go on to the next problems in the next video.